In this video, we will talk about De Morgan's laws. De Morgan's laws provide negations of statements combined with and or. Let's look at these two statements first as an example. The first one says it is raining or it is sunny. So we want to find a negation of this one. And like it says here, a negation should make the given statement completely false. The statement it is raining or it is sunny is true as long as at least one of these two is happening. So when you say it is raining or it is sunny, it could be just raining. It could be sunny, or it could be both. So to negate this, we don't want any of these three to happen. That means the negation will be it is not raining and it is not sunny. This is the negation. This way it is not raining, it is not sunny, and both of them are not happening, of course. Now let's look at this sentence, this statement, it is raining and it is sunny. So in this case, both of them are happening. Both of them are happening. To make it completely false, we want at least one of them not happening. So the negation will look like it is not raining or it is not sunny. That means at least one of them is not happening. That means it is not happening that it is raining and it is sunny. So this is the negation of it is raining and it is sunny. So if we write this in symbolic form, let's denote raining by R and sunny by S. The same thing here, R and S. So here we are given R or S in the symbolic form. Here we are given R and S. And let's see what we got for the negation. We got not raining, so not R, and not sunny, not S. So this is the negation we got. Here we got not raining, not R, or not sunny, not S. So this is the negation for R and S, and this is the negation for R or S. And formally, we have the formulas here for De Morgan's laws. The negation of P or Q is not P and not Q. The negation of P and Q is not P or not Q. These we call De Morgan's laws. Next, we will look at some examples. So here we will use De Morgan's laws to negate the following statement. Today is Tuesday, or today is January. So here if we denote Tuesday by T and January, so we'll denote today is Tuesday by T, and we'll denote today is January by J. So we have given here is T or J. So we want to negate that. We are trying to find negation of T or J. Now we can use one of these two formulas. The first one seems to apply here. Then we get, using that formula, we have not T and not J. So let's write it back in terms of what we are given. So not T means today is not Tuesday, and so we have and here, and today is not January. So this is the negation of today is Tuesday or today is January. The next example here, I eat rice for dinner or I stay hungry. Let's denote the first part by D. I eat rice for dinner. Let's denote the first part by R. The statement I eat rice for dinner is R. And I stay hungry. Let's denote that by H. So we are given R or H, and we want to negate this. So we want to find the negation of R or H. And we can apply this formula again. Using this formula, this given expression is equivalent to not R and not H. Then we have not R is, now we can translate it back in terms of the statements we are given. Not R is I do not eat rice for dinner. And we have and in the middle, this one here. And I do not stay hungry. So this is the negation of I eat rice for dinner or I stay hungry. Let's look at the next example. My watch is fast or the bus is late. Let's denote the first part, the first statement by W and the second one by B. The W is the statement, my watch is fast, and B is the statement, the bus is late. So here we are trying to find not W or B, and using the De Morgan's laws, this is simply not W, using this law here, not W and not B. Now let's write it back in terms of the given statements. W is my watch is fast, not W is my watch is not fast, and not B is the bus is not late. This is the negation of my watch is fast or the bus is late. The next example here, which is very similar to the last one we did, but here we are combining by and. Again, let's denote the first part by W, the statement my watch is fast, and the second part by B, the statement the bus is late. So here we are trying to find negation of W and B. W and B, we can use this formula. So this is equivalent to not W or not B. Now let's write it back in terms of the given statements. Not W is my watch is not fast, or we have or over here. The bus is not late. So this is the negation for my watch is fast and the bus is late. The next example here, X is an even number and X is divisible by 2. Let's denote this part by E, and let's denote this part by T. So here we are trying to find negation of E and T. This will be not E or not T using this formula. The not E is the statement X is not an even number, or we could say X is an odd number, or not T. So T is X is divisible by 2. Not T would be X is not divisible by 2. Let's look at the next example now. Here we have X is greater than or equal to 2 and X is less than 7. So I can split this into two sentences like that. So let's denote the first one by T and the second one by S. So here we are trying to find negation of T and S. So again, applying the De Morgan's law, this one over here, we get not T or not S. So not T is the negation of this statement, X is greater than or equal to 2. Its negation will be 2 is greater than X. Then we have or X is greater than or equal to 7. So this is the negation. X is less than 2 or X is greater than or equal to 7. Now if we think of this in terms of number line, the given statement says X is between 2 and 7, including 2 and not including 7, like that. So this is the reason given by this inequality. Now negating that means we include X values other than the ones given in this number line. So it should be all the values below 2, these ones, and the ones above 7, including 7. And that is exactly what we are given here. So the first part, this part is 2 greater than X, or you can write as X less than 2. And this part is X greater than or equal to 7. We have another example here. So let's divide the first part into two parts. We have 2 less than or equal to X and X less than 7. So we have this as one part, and then we have or X greater than 10. X greater than 10. So we have three statements here. So let's denote the first one by T, second one by S, and the last one by E. So we have statements T, S, and E, and we want to find the negation of T and S is the first part, or E is the second part here. We can apply De Morgan's law between these two statements. So we have P, our P is this one and Q is that one. So we have P or Q, then this law applies. So this is equivalent to not P, that means not T and S, and not Q. Our Q is simply E, not E. So we get this. Now we need to go one step further, applying De Morgan's law to the first part. We have not T and S. This time we apply this law. So this will become not T or not S and not E. So we have this. Now we can write this back in terms of the given statements. So the first part is not T or not S. We have not T would be 2 greater than X, or Not S would be X greater than or equal to 7. And then we have and, not E. Not E is X is greater than or equal to 10. So this is the negation of this given expression. And we can confirm that we got the correct negation by trying to draw normal line for this one and for this one. I will let you do that.